Where did I get that? Emily?
From where it says R sin x cos alpha, so 3 equal R and cos alpha.
Yeah, you just think what's multiplying by the sin x? Over here it's a 3, over here it's a R cos alpha. They need to be the same. Yeah? Get this, 4 needs to be a simplified version of R sin alpha. Yeah? Or else how on earth is our wish going to come true? See, what's with the cos x here? 4. What's with the cos x here? R sin alpha. You cool with that, Dad?
Yeah.
Jody, you cool with that? Yeah. Sonia, you cool with that? Zoe, you are? How about you, Gabby?
Yeah.
You guys cool with that? Now, what topic are we in? Simultaneous equations, right? 2 equations and 2 unknowns. And check this out, it's beautifully lined up. See, equals under equals, number under number, R under R, trig under trigger, trig under trig, alpha under alpha. What do you normally do when stuff's beautifully lined up? You do 3 subtractions or 3 additions. Yeah? Don't do that here. The reason why we do 3 subtractions here is because that achieves a blank. 2x take away 2x is 0. You can never need to write a 0 next to something, so why bother? That's why it comes out blank. That will not work here, but what will? What will cause a blank? 0 is not the only number which you can leave out when it's next to something. What other number can you famously leave out when it's next to something? 1. The number 1. Whoever bothers writing 1x when they can write x? So, what am I going to do? I'm not going to do 3 subtractions, 3 additions. I'm going to do 3 divisions. Get this. 4 divided by 3. 4 over 3. R divided by R, 1. Sin theta divided by, sin alpha divided by cos alpha is score. How beautiful is that? Okay? And I'll leave out the 1 obviously. And get this, that fits the peanut template. Which means you can just swish it straight into the calculator. There's a million answers. You only need 1 because all you want to do is have something that makes this the same as that. And the rules of the game is that we always take the acute angle. Just a nice simple acute angle, which I think is 53.1. Okay? Now, remember we're still in simultaneous equations. Is that focused properly? Oh man. Okay, that's much better. Basically, we take videos so that people can do stuff at their own pace. Some students have already seen this, but the reason why there wasn't already a video is because I forgot to press record. Okay. Now, what do we normally do to get the other answer? You substitute back in, right? Yeah. Did anyone ever advise you that for tricky questions that had lots of fractions and negatives, it was better just to do the question again? Did anyone ever say that?
Yeah. Just
do the question again, but instead of eliminating y, eliminate x?
Yeah.
Has anyone ever said that, Amy? It can be the business, especially if your first answer was a fraction. Yeah. Because if you do nice matches, you only get a fraction at the end. So just do it twice, get 2 fractions at the end, but they won't screw you up because you got them at the end, right? Okay. Now, for a different but similar reason, I do not recommend substituting this back in. Okay, and the reason is that sometimes you get an exact answer, and if you substitute it back in, it's more likely that the calculator will give you a decimal without you realizing that it was exact. Now, you all know, I hope, that is a famous trig thing. What does that come from? Sin 45, cos 45. But I bet none of you knew this. I bet none of you know this. Does anyone know where that comes from? That's sin 15, right? Yeah? And what I'm saying is, some things you just don't have the general knowledge to know. Therefore, if a particular decimal came out, you wouldn't know if it was significant. So the method I'm going to show you guarantees that you realise that there's an exact value if there is one. Does anyone know what surd that is? Ish? It's root 3. Does anyone know what that is? Ish? If that came out of a calculator, would you guess that it was intending to be root? Obviously not, since you're not saying it now. If that ever comes out of a calculator, it's pretty likely that it came from root 2. Okay? I take it you all know what that is. Hmm?
Root 5.
No? Do you want to know what that is?
Pi times
Pi times 2?
Root 10.
No, that's pi.
That's pi.
What's that?
Is that the E?
That's e. This is this totally demonstrating my point. Certain famous decimals you're so used to seeing in their exact form that you forget what the decimals are.
We need pi.
That's why I'm going to recommend doing this question again, but this time eliminating alpha instead of r. Now watch this. If you thought that was clever, check this out. I'm going to square the first line. 9 equals r squared cos squared alpha. I'm going to square the second line. 16 equals r squared sine squared alpha. I'm now, even though it seems crazy because I'm not going to get a blank, I'm going to do two additions. 25 equals r squared cos squared alpha plus r squared sine squared alpha. Now, the next thing we're going to do is a bit of Dear Mr. Examiner. Dear Mr. Examiner, I'm in a bit of a tight spot, but I'm going to show off my algebra skills. What algebra skills can I show off here, Freya? Just with this side?
I don't know.
Does anything look patterny about this? Like it's not an accident? Like it would be in an algebra test?
Could you square?
Just factorising. Yeah, see how there's a common factor? Yeah, so what do I do? Write the common factor once, open up a bracket, write what it used to be with. You've done that 1,000 times. Yeah? Now you 13 punks, why is that sweet? Because cos squared theta plus cos squared alpha plus sine squared alpha is 1. Isn't that amazing? The cleverest thing ever, right? And r, therefore, is 5 or negative 5. We only need one of the values, right? Because all we want to do is to be able to make this equal to something like that. And we've done it. 3 sine x plus 4 cos x for every value of x in the whole wide world is equal to 5 sine x plus 53.1. There we go. Double appearance, single appearance. Easy, hard to graph, easy to graph.